as a starting point, people still use sometimes just batch tests, or they use a pilot test that is performed in a lab or on site to go to to a full-scale installation, or to make a design for a full-scale installation. And how this batch test is performed, or the conditions in this batch test, have an important effect on the results of this batch test and on the conclusions you draw from this batch test to your future design. So it's, you need to be aware of these assumptions from these tests and know what can be the impact on your overall design. Roberta will show you in a live demo a little bit more on this topic and what is the importance of these batch tests and what is the sensitivity of these batch tests on the overall performance of your system. So now I give the floor to Roberta, and we are going live to Italy.
Yeah, thanks, Peter. Hello, everyone. And so let's see in one simple but meaningful example, what is the impact of, for instance, human factor when we are dealing with batch experiment. So imagine we are in the lab and we are using a certain ozone stock solution. We are pouring this ozone stock solution in the beaker containing 1 liter of our secondary effluent sample. So we are dosing 0.25 liter of stock solution with a certain ozone concentration, in this case 50 milligrams per liter, and we'll see the effect on the injection speed. So let's first assume that we are injecting ozone in the ozone stock solution within 10 milliseconds. So a very fast ozone injection speed. Let's see what happens in terms of ozone profile and ultimately in the bromide formation. So what we can see is that there is, if we zoom in, a big jump in the ozone concentration in the beaker, because we are injecting ozone in only 10 milliseconds. Then what we can see is a drastic drop within the first seconds, 3 point something seconds, and then a gradual decrease in the ozone concentration. In terms of bromide formation, we can see the bromide is being formed within the very first seconds. It's already 18 micrograms per liter, and then it's gradually increasing till the end of the experiment, 28 micrograms per liter, due to the presence of residual ozone concentration. But now let's see what happens if we increase the injection time. So we are now injecting the ozone stock solution, same volume, same concentration, within 2 seconds. So let's see what happens again in terms of ozone concentration and bromide formation. So what we see is that we reach a lower ozone concentration in the beaker, in the liquid phase. Why? Because meanwhile we are injecting, the ozone reaction are happening. So at the same time, the ozone is being consumed. So we see again a same pattern with a drastic drop and a slower ozone decay afterwards. And in terms of bromide formation, we can see that bromide is again formed within the first few seconds, and we reach 13 micrograms per liter after 3 seconds, more or less, and ultimately at the end of the experiment we reach 24 micrograms per liter. So we have seen within 10 milliseconds we're forming 28 micrograms per liter. Now within 2 seconds of injection we are producing less bromide, 24 micrograms per liter. Now let's see, last example, what happens if we inject ozone within 40 seconds. So let's see the results now in terms of first ozone residual. So the ozone in the liquid the peak of ozone in the liquid is now after 40 seconds, because we're injecting ozone within 40 seconds, and is 3.5 milligrams per liter of ozone. And then the ozone is being consumed by the water matrix. In terms of bromate, we can see that now bromate increases smoothly, let's say, within the first seconds, and then it reaches an bromate formation at the end of the test of 14 micrograms per liter. So what conclusion we can draw from this? If we inject ozone, the ozone stock solution very fast within a millisecond, which is rather impossible, we end up with a higher bromate formation. But if we inject ozone in a longer period of time, 40 seconds, we can actually see a bromate formation up to 50% lower. So this is very important to know, to evaluate the results of a batch experiment. It's very important also to know this detail about the human factor and the operation of such tests. Thanks. I leave the floor again to the presentation.
Thanks, Roberta, for sharing the demo. It was very nice to see how sensitive batch tests are on how they are performed. So the reason why we highlighted batch tests here is because they are the extreme example illustrating how sensitive not only the matrix, but how you set up piloting or batch lab experiments are to the conclusion. So it's all about the assumptions. How long do you dose? How do you mix? And that's very, very interesting, because if you obtain a certain bromate level in the lab, you might use it to extrapolate to full scale, but that might be an issue in a later stage because it's not really representative. And we can actually take it one level further. And what is currently on this slide has never been shown before. And you will also not find it in academic literature. So this is really like the first time ever we show this, and we will use them a lot, these insights, because they are quite disruptive. I mean, what we are doing now is we are coupling a CFD model, which is a 3D model, with the kinetic model, and we are simulating with a CFD model exactly the same batch test as the one Roberta has shown. But the difference is we will look into 3D. So what you will be seeing here is movies of the local concentrations of ozone, bromate, and diclofenac, one of the micropollutants. So red means 100% diclofenac, and if the color starts disappearing, we are removing it. And ozone, of course, is dosed at this site. You can already see it happening. So let's look, if we dose ozone, what happens with the ozone level in this batch test. So we see a cloud, a local cloud is going around, and in this test, we are only visualizing the first 3 seconds because a lot of things happen in the first 3 seconds. So you have seen that actually you have a local cloud of ozone, which is actually even in a little batch test of 200 milliliters, not very well mixed, but the kinetics are way much faster than the mixing. And this brings us to bromates. If you see where the bromate occurs, it all happens where you add the ozone. So I will play it again, and you have to pay attention to this red spot that will appear right at the beginning of the movie. So I play it again, and you can see there's a red spot, which is a huge local bromate concentration that happens because of the local kinetics with the local high dissolved ozone levels. If you look at it from the top after 1 second, you can see that you have a red cloud of bromate being formed in your system, driven by the local high ozone concentration that is very poorly mixed, but all of a sudden introduced in your beaker. If you look at diclofenac, of course, we have a removal. So you start seeing a cloud that starts, let's say, eating away the diclofenac, which is, of course, the ozone. With this system, of course, it's a bit at a lab scale, but you can just do it exactly at full scale, which we are actually doing at full scale plant design. And this brings us to, actually a new insights of how these systems can be better designed. So you have to really consider, first, at a small scale, how you extrapolate results from it. And second, if you design a full-scale plant, you really have to consider these kinetics. So the key point, what we wanted to address with this section is batch and pilot tests are meant to gather information for a future full-scale. but batch and pilot scale designs are often not representative to make this extrapolation. And that is really a key message we wanted to give here. You have the matrix, okay, you have your ozone dose, that's fine, but please bear in mind that how you set up the tests at smaller scale are equally important for your conclusions. And we have seen really a lot of practical insights there, and we have talked to a lot of practitioners that have witnessed this with extrapolations. So be careful, your assumptions matter. That is the key message here.